question number 12. So for question number 12, let's take the original number of boys as B, a capital B, and the original number of girls as a capital G in the older class. Now, the question says that the number of boys has increased by 20%, right? It has increased by 20%. So, let's say that the original number of boys is 100% because the original is always 100%, right? The new number of boys, let's take that as Bn, has increased by 20%. So that's 100% plus 20% is 120%. Now when you cross multiply, you have the new number of boys Bn is 120% of B. Let's move back to decimal places, and we now know that the number of boys in our new class is 1.2b. We're going to apply the same working for the number of girls, right? So the original number of girls is always going to be 100%, and the number of girls in our new class, if you remember, the number of girls has decreased by 20%. That's 100% minus 20%, that makes it 80%. Now cross multiplying, we have the new number of girls is 80% of the original number of girls, that is 80% of G. Moving back to decimal places, we have 0.8 G. So now we know that the number of students in our new class is 1.2b, the new number of boys, plus 0.8 G, the new number of girls. Okay? And this is equal to, now we also have another possible expression for the number of students in our new class. That is, we now have one student more than before. This means that the number of students in our new class is B plus G, that is students in our old class, plus 1 for the extra student. We don't know whether it's a boy or a girl, but we do know that there is just one extra student. Now if we simplify this, we have 1.2 minus 1 is 0.2b, 0.8 G minus G is going to be minus 0.2 G equals 1. So let's take that as equation number 1. 0.2 B minus 0.2 G equals 1, right? It's equation number, that's equation number 1. Let's move on to finding out a possible equation 2 in order to solve our expression simultaneously. Okay, so for equation number 2, we're going to use a trial and error method using all of these options that they've given us. These options are for the number of students in my class now. So let's assume that A is our correct answer, right? If A was our correct answer, we would have the number of students in our new class is B plus G plus 1 equals 22. Now if we simplify this, we have the number of girls, that is G, equals to 22 minus 1 is 21 minus B. This would be equation number 2. Like inserting 2 into 1, we have 0.2 B minus 0.2 times the number of girls is 21 minus B equals 1. Let's simplify this further. We have 0.2 B minus 4.2 plus 0.2b equals 1, which means that 0.4b equals 4.2 plus 1 is 5.2, and b equals 5.2 divided by 0.4 is 13. Okay, and the number of girls, it turns out, is 21 minus b. So the number of girls is 21 minus 13, which is equals to 8. Right, so this far it looks like A should be our correct answer, because 13 plus 8 is 22, 21, and so on. But there's a catch. If you look at the number of students in our new class, you will remember that we figured that the number of boys equals 1.2b. Remember? So it's 1.2 times 13, and that works out to 15.6 boys. Now, you can't really have a fraction of a boy, can you? You can either have 15 boys or you can have 16, but you can't really have 0.6 of a student, right? Similarly, the number of girls in our new class works out to be 6.4. You can't really have a fraction of a girl either. And so, because you can't really cut students into pieces, this cannot be our correct answer. Now, the way to solve this question would be to apply the same trial and error method for all of these options. But I've marked out B, which is our correct answer, so I'll show you how the correct working should look, what the correct working should look like. Alright, let me choose another color. So if B was our correct answer, a correct assumed answer, we would have B, I'm working faster now, plus G plus 1 equals 26. So G would be 26 minus 1 is 25 minus B. Now if we insert this into equation 1, we have 0.2B minus 0.2. In place of G, I'm going to put in this expression. That's 25 minus B equals 26. Sorry, equals 1. Okay, so this works out to be 0.4b. I'm skipping steps in the middle. Minus 5 equals 1. B equals 6 upon 0.4 makes it 15. Right? And the number of girls in our original class is 25 minus B is 25 minus 15, and that works out to be 10 girls in our original class. Now, this is working out really well because the number of students in our original class has to be 25, and 15 plus 10 is 25. Now let's see if it works out for the number of students in our new class. So the number of students in our new class is, for boys, it is 1.2 times 15. And that, it turns out, is 18 boys in our new class. And the number of girls in our new class is 0.8 times 10. And that is 8 girls. Right, now if you add these two up, you get 26, which is the perfect number for the number of students in our new class. All the students are whole numbers, and all the sums are exactly as we want them. And so we will take B as our correct answer. Now I'll just give you a look at my blog. The link is in the description box below. It would really help. You can see if it helps you out. It has a complete list of work solutions for all our questions, right? So this is what it looks like. I've given you a complete explanation in words, and just see if that helps you out. I have all of the answers, a complete list with pictures and everything that might help you out. Do check it out, and hope it helps.